To start today's lesson, we're going to take a look at the problem of the day here. So I would encourage you to pause the video right now, try these on your own, see how you do, and then start the video again when you are ready to check them. So go ahead and pause the video right now. Alright, let's check the problem of the day. So the first one here, we have to classify each of these angles as acute, right, obtuse, or straight. So ABC, if we trace that one out, I can see that that is an acute angle. Okay, let's take a look at the next one here. So DEF, if we trace out DEF right here, well, I see that we've got the right angle box on that side, so that means DEF is also a right angle. Okay, the next one, ABE. So ABE. Okay, if we look right here, we can see that that angle is bigger than 90, but it's not up to 180, so it's between 90 and 180. That makes it obtuse. And then last but not least here, BEF. Okay, if we trace out BEF, it ends up just being a straight line, which means it is a straight angle, and it would be 180 degrees. Okay, moving down to the next one here, classifying each pair of angles. Okay, so we have ABC and ABE. So ABC, ABE. So we're talking about these two angles right there. So we need to choose between vertical, adjacent, complementary, or supplementary. Well, these happen to be two of them. They are next to each other and they share ray BA. So they are adjacent. And they go together to make a straight line, so they're also supplementary. Okay, then the next one's here, ABE. And CBH. So we're talking about this angle and this angle right there. Well, those are vertical angles. Okay, they're across from each other. We know that they would be congruent. The next set of angles, ABE and EBH. So we're talking about this angle and this angle. Okay, well, they share the vertex and they share side BE, so they would be adjacent. And they go together to make a straight line, so they would also be supplementary. Number 3, we're moving down to this diagram down here. We need to find the measure of each of the following angles. Well, it gives us that E is 22, so we know that N is 22 because N and E are vertical. So we know angle N is 22 degrees. Okay, for angles A and S, okay, if we look at angle E and angle S, well, we know that they must go together and make 180 degrees. So if I take the, so angle S is going to equal 180 minus 22, so angle S is going to be, the measure of angle S is going to be 158 degrees. And if angle S is 158, that means angle A is also 158 because S and A are vertical angles. And last but not least there, number 4, count the sides here. We got 1, 2, 3, 4, 5, 6, 7 sides. That makes this a heptagon. Okay, so double check those, make sure you got them. We're going to move on to today's lesson, which is on angle measures in a triangle. So you can see the objectives here. We need to prove that the sum of the measures of the angles in any triangle is 180 degrees. We're going to prove that the measure of any exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Lots of words there. And then what we're going to do is use that information to find the measure of an angle within a triangle. So to start with here, it says any triangle is made up of 3 sides and 3 angles. The sides and angles of triangles share relationships that can be proven. So the first thing we're going to prove here is that the 3 angles of any triangle can be put together and add up to 180 degrees. And the way we're going to prove that is we are going to cut these angles out. So I'm going to trace angle A here. And I'm going to take angle A. And I'm going to take it over here and line it up on this line. Okay, then I'm going to take angle C. I'm just going to trace a little bit of angle C. I'm going to take that angle, and I'm going to put the vertex next to the one for angle A and put it there. And then I'm going to take angle B. I'm going to trace that out. I'm going to take angle B. Now angle B, I want to put it right in here between angles A and C, so I'm going to have to rotate this one a little. And it should fit pretty close in there. Okay, as you can see, we put those 3 angles together. They form that straight line there, which means that all 3 of these angles together are going to make 180 degrees. Okay? Now, since the 3 interior angles of the triangle form a straight angle, and the measure of a straight angle is 180 degrees, the sum of the 3 interior angles in any triangle is 180 degrees. Okay, you can use this angle sum theorem to solve problems like the following example. What's the measure of the third angle? Well, you know that if you add up the 3 angles, they should add up to 180 degrees. So the x plus 60 plus 85 should equal 180. 60 plus 85 is 145. So something plus 145 equals 180, and that would be 35. And what you can do is just take 180 minus the 145 there, and that will give you the 35 degrees. Okay, angle measures, or exterior angles of a triangle. We're talking about an angle on the outside of the triangle if we extend one of the sides. And what it's saying is any exterior angle of a triangle is supplementary to the adjacent interior angle. So if you look at this 30-degree angle right here, this exterior angle of 150 is supplementary to it because they're going to go together and add up to 180. Now the other rule with this is the sum of the measures of the 2 non-adjacent interior angles in any triangle is equal to the measure of the exterior angle. So the non-adjacent angles, remember adjacent angles are next to each other. So this is my exterior angle right here. Okay, the 30-degree angle would be adjacent to it. So this one would be adjacent. These 2 over here in the blue would be non-adjacent because they are not next to the exterior angle. Okay, so if you look here, if we take the 80 degrees plus the 70 degrees, that adds up to 150, which is the same as the exterior angle, which is BCD. So that's what this formula at the bottom is saying. The measure of angle A plus the measure of angle B. Angle A is 70, angle B is 80. That's going to equal the measure of angle BCD, which is the exterior angle. Okay? Okay, so an example here, we have the exterior angle of the triangle is the 130, and these are the non-adjacent angles right here, the non-adjacent interior angles. So if we take the 60-degree angle plus the measure of angle x, that should equal 130 degrees. So all we got to do is take the 130 minus the 60, and we get that x would be 70 degrees. Okay, so to find the measure of angle x here, in this first one, we're just going to go ahead and we're given 3 interior angles of the triangle. We know that they have to add up to 180. So here's what that should look like. So we take 50 plus 60 plus x equals 180. 50 plus 60 is 110. So we have 110 plus x equals 180. Subtract that 110 and we get that x equals 70. Okay, number 2, same thing. We have 3 interior angles of a triangle, so we know that they should add up to 180. So we're going to go ahead and set that up and solve it. Here's what that should look like. So for number 2 here again, we're taking x plus 100 plus 30, adding up those 3 interior angles, they should add up to 180. 100 plus 30 is 130. So x plus 130 equals 180. Subtract the 130 from both sides and you get x equals 50. It would be 50 degrees. All right, now number 3, we have an exterior angle and we need to know one of the non-adjacent interior angles. So remember, the 2 non-adjacent interior angles will add up to the exterior angle. So here's what that would look like. So what we have here is x plus 20 is going to equal 75. Again, the 2 non-adjacent interior angles add up to the exterior angle. Subtract the 20. 75 minus 20 is 55. Now, with these types of problems, if you can't remember that rule that the 2 non-adjacent add up to the exterior, you could still figure this out, because what you could do is find this angle down here next to the 75, because that angle and 75 have to add up to 180. So if I took the 180 minus 75, okay, I would get 105. So then I would know that this angle right here is 105 degrees. Okay, now I know 2 interior angles. I can find the third, because I would know that x plus 105 plus 20 has to equal 180. So 105 plus 20 would be 125, and then subtract the 125, you would still get x equals 75. Or I'm sorry, 55. X would still equal 55 degrees. Okay? Okay, next one, same as the one before. I'm just going to do this one using the rule that the 2 non-adjacent interior angles will add up to the exterior angle. So here's what that would look like. So for these, we would have x plus 97 equals 110. Subtract the 97 from the 110, you get 13 degrees. All right, to finish up, go ahead and try the learning checks here, and then come back and check them to make sure you're correct.